Welcome back. We're in lesson 110. We're going to talk about solving quadratic inequalities. We're going to begin with the greater than proposition. If we want to say that x is a positive number, we can write it as x is greater than 0. We know that that is a positive, right? It has to be starting with positive 1 or even positive 0.5 is going to be greater than 0. So that is how we could write all letters or all positive numbers. X is greater than 0. What if we had a quadratic equation? We would have factors, right? We would factor it into binomials. So this would have to be a positive number, and this would have to be a positive number to be greater than 0, because a positive times a positive is greater than 0, but also a negative times a negative is greater than 0. So how do we account for that? First of all, put that in your notes. And let's just jump right into our first example problem and kind of give ourselves an illustration that helps us understand. Let me clear the page. All right. So you can see what I mean by having factors here. We're going to solve this for the domain of real numbers. X plus 2 times x minus 3 is going to be greater than 0. So we know this is going to be a positive number. So how do we get there? So let's look at first the possibility that both of these are positive numbers. Positive times a positive, right? So that means if it's a positive number, it's going to be greater than 0. So we'll set the first binomial greater than 0, and then we'll set the second one greater than 0. So that's the important part here. All right, this is what we're learning. Let me write this in a different color to draw attention to it so you will pay attention. Greater than 0, greater than 0. That's if it's positive, right? Okay, so let's move on. Now we're going to, this is what we know to do already. We're going to subtract 2 from both sides, so x is going to be greater than negative 2, and then we're going to add 3 to both sides. X is going to be greater than a positive 3. When we get to this point, now we know we have our conditions, and both of these have to be true. So where are both of these true? In which statement are both of these true? If x is greater than negative 2, then it's also greater than a positive 3, right? If x, let's say x is a positive 4, is it greater than a negative 2? Yes. But if x is a negative 1, or let's say it's a positive 1, positive 1 is greater than negative 2. Is positive 1 greater than 3? No, it's not. But if it is a positive 4, then this statement is true as well. So we have to use this statement for both of these to be true, right? If it just is true for this one, then it does not include both conditions. So we have to go with this one to make both of these correct. All right. So, and the reason for that is when you sub it back in, if I were to put in 4 plus 2 here, I would get 6. 4 minus 3 here, I would get 1. So positive 6 times a positive 1 is a positive 6, which is greater than 0. But if I were to use, let's say I were to use a positive 1 from this side, I would go back and sub it in. 1 plus 2 is 3, that's positive 3. But then a 1 minus 3 would be a negative 2. That'd be a positive times a negative, which would not be. It'd be a negative answer, and it would not be greater than 0, so it would not be true. So we have to use the one that is true for both sides of the binomial. All right, and so that means this one is not usable. So there's one side when they're both positive. Now we have to take into account if they are both negative. So negative and a negative times each other. So we're going to say x plus 2. For a negative, it's the opposite sign, right? It would be less than 0 because that'd be negative 1 and so forth. And then x minus 3 would be a less than 0 as well, right? So we have to have a number that we can sub in for both x's that meets both conditions so that they're both negative. So let's solve for that. So we subtract 2, we get x is less than negative 2, and x is less than a positive 3. One of those has to be true. So if x is less than a negative 2, is it going to be less than 3? Yes, it will. It's true for both statements. But if x is less than 3, let's say it's a positive 1, is positive 1 less than 2? No. No, it's not. So we can't go with x is less than 3 because then some of those answers would make this an untrue statement. So we can't do that. So now if we say negative 3, for instance, right? We could say negative 3 because that's less than a negative 2. Negative 3 plus 2, that's a negative 1. Negative 3 here would be a negative 6, so that would be negative times negative would be a positive 6. So you see how that's working? Yes, right. It's all about making sure that both of these answers are negative when we do this. That's why we have to find the statement that makes both of these true. They both have to be negatives. And this one would make both of these a negative number. Now we can graph. Now that we have our positive solution and our negative solution, we can graph it on a number line. Here's my 0 in the middle. And 1, 2, 3, 4, 5, 6. I know these are not perfectly even, but they're pretty close. All right, well, sort of somewhat representative. How about that? So we're going to graph this one first. X is greater than 3, and remember the domain is reals, so it's all the numbers. So if x is greater than 3, then we find the 3, 1, 2, 3. It is not an equal sign, so we put a circle and we put our line this direction. And now we say x is less than negative 2, so we find our negative 2. We circle it, there's not an equal sign underneath it, and we go to the left to solve that one, to graph that. And that is how we would graph those quadratic inequalities. All right, let's look at 110.2. All right, in 110.2, we are asked to graph this quadratic equation, or quadratic inequality, in the domain of integers. So first of all, we need to put this in a format that we can use and that we can factor. So that's going to be x squared minus 2x minus 3 is greater than or equal to 0. Now we can factor this, and that is going to be x minus 3, x plus 1 is greater than or equal to 0. Now we have it factored, so we can do positive, positive, negative, negative. So with a positive times a positive, we're going to say x minus 3, and if it's a positive number, it's going to be greater than, and we have an equal to sign, so it's going to be greater than or equal to 0. And then the other one is going to be greater than or equal to 0 because it is also a positive, positive, positive. So it has to be greater than 0. Now for the negative side, we have a negative times a negative to give us a positive number, right? Because this is greater than. So we're going to say x minus 3 is less than or equal to 0, and x plus 1 is less than or equal to 0, right? Because negatives are less than 0. So now we solve. This would be x is greater than or equal to 3, and x is greater than or equal to negative 1 here. This will be x is less than or equal to positive 3, and x is less than or equal to a negative 1. Now we look at our positive condition, and we figure out which one is true for both. So if x is greater than 3, greater than or equal to 3, it's going to be greater than or equal to a negative 1, right? If x is greater than or equal to negative 1, let's say it's negative 2, negative 2 is not greater than or equal to 3. So we can't use conditions here that are true here. So therefore, that's not the one we can use. This is the one that is true for both. Now, if I said x is less than or equal to 3, I could have a positive 2. If I put positive 2 in here, positive 2 is not less than or equal to negative 1. So I can't use all the solutions here. So therefore, this one is not true, and this is the one that we will use, right? Because everything that's less than a negative 1 is less than a negative 3, or less than a positive 3. So this is true for both statements. This one is not. So that's how we cancel. So now we're going to graph that. And remember our domain. Ooh, I like that nice little line. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So I have x is greater than or equal to a positive 3. It's in the domain of integers. Here's my 3. So because it's integers, I'm just going to make a dot on top of the integers that are equal to 3 and greater than 3. Okay? And now I'm going to make a dot on the integers that are less than or equal to 1. This is a negative 1. So equal to or less than just the integers. So I'm just going to make that dot. All right, and that is how we would graph this solution. And that is all we have for lesson 110. If you have any questions, please ask. And I will see you in lesson 111.